Boleh masuk kelas dah.
Assalamualaikum warahmatullahi taala wabarakatuh. How are you? Semua sihat eh? Okay, alright. Before we start, anything from last class? Any question about the homework problems that I give you? Okay, okay semua. Okay. Today we're going to finish up this chapter number 14 on the partial derivative. We're going to look at the application on what we learned last class about the second partial derivative. And then we're going to look at the part of the chapter that is on the Lagrangian multiplier method. It's 14.5, the last part. And then when we finish that, we think we move on to a new topic that is on the integration. So that will be our plan. I want to also discuss about our midterm. Now I look at the calendar. We have now, okay, we are now in the second week of the second half. So we have 4 more weeks after this week. So I want to plan for the final. Not for the final, for the midterm. Today is the second week, second half. That means week number 6, 7, 8. I think now it's week number 8. Week number 8. Okay, week number 8. So you have 7, 8. So I would like to have the test week 8, week 9. Probably, most probably lah, on week number 10. Okay, so we're going to have the test. The midterm. So test would be on that week number 9. So the test, test. Week number 9, that is on the Monday. Okay, that will be on Monday, 14 December 20. All right. So that is our plan. 14 block. 14. Today is already Wednesday. Today is the 9th. No, not the 14th. 14 will be too early, you know. 21st, the week after that. Okay, that will be week 10. Okay, week 10. Okay, 21st December, 20th. So that will be the date for our midterm. Apa cakap ni? 21st. So that will be. Okay, we'll do it in class time. During class time, maybe I give you 1 hour or 1 hour 5 minutes. We'll submit just like what we did for the quiz. Okay, all right. And the coverage will cover up to this topic. This topic they're going to finish this week, hopefully by today. Okay, that will cover up to this week. Okay. So that is the now I'll give you notice quite ample time. Okay, so I would like you to prepare better. You know, I already discussed about the quiz, so hopefully the midterm we can do better. Okay, so that is the test. Okay, we're going to continue with the application. Application for this chapter on that part, the second derivative test. Go to 14.4 application. We have done the application 14.3. Okay, I ask you to click on the demand function. I give you some questions. So now we're going to look at 14.4 application. So let's look at example number 4. Now, example number 4 is on the profit. So you have a profit function, and then you want to maximize, and of course, that profit function is a function with 2 independent variables. So we need to find the output level that would maximize the profit, and then you want to determine the maximum profit. So let's look at the example number 4. So application here, we look at example 4 on 14.4. That is on the profit function. So please read that function block. Read that example. Okay, just spend 1 or 2 minutes reading that example so that we know what is that problem about. Okay, go through that thing. Okay, you read it? Okay, now this example, you have a function with 2 independent variables, and that function is profit, and you want to maximize the profit. You want to find x, y. So in other words, in our application, okay, that this is the concept. You want to find the value of the xy that maximizes the function z equal to f of xy. And then you want to find the maximum z, okay, or the value of the function. So in other words, what we are looking at is actually the maximum point. So the maximum point of the function would be equal to x, y, z, or we call it x star, y star, z star. So that's the point. You want to find the maximum point, or you want to find the minimum point. And the problem can also be minimization. So You want to find xy that minimize the function. So you want to find the minimum value of z or the function. Okay, so that is what we're doing. Now, if you look at that example, we are talking about profit, and the profit of the firm that is selling 2 products. You call it what? We call the products, so that company, Adderley Lamb, producing 20-inch lamp. So you got a 20-inch lamp. And then you got the other product, which is 31-inch lamp. So these are the 2 products. So we call this X. You call that Y. Okay? And then you want to find the profit function. And we are given the prices, the demand. So from the prices or the demand function, you get the revenue. So again, here, you go back to the basic. Profit is equal to what? Is equal to revenue minus cost. Now, in this example, the cost is given. So this one shouldn't be a problem, right? Cost is given. Cost is just simply 2xy. But we have to find the revenue. Now, what is revenue? Anybody remember what is revenue? What is the formula for revenue? How do you get revenue for the one good case, one independent variable case? How do you get the revenue? Price multiplied by the x. Okay, so that is the basic formula for revenue. Now, in terms of when you have 2 goods, all right, when you have 2 goods or 2 services, then the revenue will be just equal to the revenue from the first good, that is the revenue from X, plus revenue from Y. Okay, revenue of Y or from Y. So the revenue will be simply the sum of the revenue that we got from X and the revenue that we got from Y. All right. So the basic formula will be just P multiplied by the quantity. So now you have 2 revenues. One is the good X, is simply P, the price of X, okay, multiplied by X. Now, what is the revenue from Y? Well, how do you get the revenue from Y? It's just another good. The revenue from X is the price of X multiplied by X. So revenue from Y, what will it be?
P times Y.
Again, P times Y. The price of Y multiplied by the quantity of Y. Okay? So it's just the addition of the revenue from X plus the revenue from Y. So therefore, you let the price of X be equal to PX. And then the price of Y be PY. So you have now 2 prices, PX, PY, the price of X, price of Y. And then the revenue is simply the sum of the revenue of each product. So you just add them up. So our total revenue, or the revenue function now becomes PX multiplied by X plus PY times Y. Or if you look at the book, they use P1, P2. So P1 is the price of X, P2 the price of Y. So it doesn't matter what notation you use. You can use P1, P2, or I use PX and PY so that it will be denoted directly to X. So that you don't have to go back, oh, what is 1? 1 is X. And then 2 is Y. So that one, you have a double notation. So we simply use PX, the price of X, and PY, the price of Y. And then given the demand function, okay, given the demand function, you have what? You have PX, which is the price of P1 here given in the book, 50 minus X, that is the demand for X. And then the demand for Y, or the price of Y, is equal to what? 60 minus 2Y. Okay? 60 minus 2Y. So therefore, your revenue is equal to 50 minus X times X plus 60 minus 2Y times Y. Or, you know, you don't have to have the bracket for the X, since you already have the X, the bracket for 50 minus X. So for the X, you don't need a bracket. So I can just, since I wrote it already, so that's okay. And multiply out. So we got 50 X minus X squared plus 60Y minus 2Y squared. So that is our revenue function. And then given the cost, okay, given the cost, given C equal to 2XY, then the profit P will be just equal to what? Since you already have the profit function, P is R minus C, and R is what you have here. C is given there. So just substitute everything. So you have R minus C. So R minus C, that would be equal to, okay, now you can put the bracket for the revenue, because the revenue consisting of many terms. Or you don't have to put the bracket for the revenue. If the cost has more than one term, then you need to put a bracket on the cost. But anyhow, yeah, I don't think we need to put the bracket, because that consists of only, you know, the term that we already have. And then you have subtraction of the cost. Yeah, I just put the bracket so that we differentiate, okay? We differentiate the revenue and the cost. So let's just do that. That's the first step. Plus 60Y minus 2Y squared. Okay, that's the revenue, everything. Minus 2XY, that's the cost. So simplify if you can. If you cannot, then that will be it. I don't think you can simplify, because the term for the cost is 2 times X times Y. And there is no such term in the revenue function. So therefore, that's it, okay? That's the profit. So I don't think we need to even break out the bracket. Or if you want to, you can break out the bracket. So that is our revenue. Now, number one, what do? You find the critical point. So find the critical point. That means the revenue, or not the revenue, the prime, the P prime is 0 point or points. So what is the condition? Px equal to 0, Py equal 0. So that is the condition for the critical point. So we find the Px, you find the Py, you will have 2 partial derivatives. So Px is equal to 50 minus 2x minus 2y. And then Py equal to what? You do the derivative, you got 60 minus 4y minus 2x. And of course, for critical point, okay, for critical point, these are equal to 0. Px equals 0, Py equal to 0. So, okay, you write them again. So don't worry, you know, you can write. Some people, they don't want to write, okay? So if you don't want to write, then I might think that you get the answer from somebody. Okay, because in the quiz, there are a few people who just give me the answer, and that's the correct answer. So how do you get it? So my assumption, not my assumption, I can suspect you of cheating. Okay, but I cannot prove lah. But there is a suspicion. So if you show me all the steps, that means I know you are doing it. Okay, so what do you have? So you have 50 minus 2x minus 2y equals 0. So that is number 1. And then you got 60 minus 4y minus 2x equal 0. That's number 2. So here you have a linear equation system of linear equations. Okay, now I want you to practice. Find the solution. The answer is given already in the book. I don't want the answer. I want you to work it out. Okay, find the solution. Okay, spend a few minutes finding the solution. The first person get me the solution, or the first person who get the solution, let me know. Okay, so don't look at the book. Okay, the book already give you the answer. Don't worry about that. I want you to find the answer by yourself using the system of linear equation. Okay, to solve for x and y. Okay, can you do it now? I give you 3 minutes. So the first person who got it, let me know. Okay, because we know the point already, but find that point. Okay, do it now. Okay, anybody got it? Okay. Okay, anybody got the answer? So here, okay, from number 1, you have y equal to 50 minus 2x. Okay, everything divided by 2. So that would be 25 minus x. And then you substitute into number 2. So what do I get? I get 60 minus 4. Okay, I think it's quite simple. The function is not tricky. So you got 25 minus x minus 2x equal 0. Is that right? Okay. You got that? And then you simplify this thing. Here you got 60 minus 100 plus 4x minus 2x equal 0. Okay. Then you got 2x equal to negative 40 from here. So that becomes 40. So x is equal to 20. Betul ke? X equal to 20. X equal to 20. So 40 over 2, that is 20. You got 20 or you got another number?
20, sir.
Huh? For about 20?
20.
Okay, so make
Yes,
sure we know
20.
how to do this. All right, system of linear function, I think now kacang, okay? Kacang putih, senang. So when you got x equal to 40, you work it out. Y equal to 5.
Oh.
So look at that. So now, that is the critical point. Okay? So you can find, or we can call it x star, or you just call it y, because it's already a specific point. Now you can find the z star if you want, but if you don't, then you can wait until the end, okay, to find it. So given that critical point or critical value of x and y, you want to test, is it a maximum or is it a minimum? So what you need to do here is you take the second partial derivative. So number 2, you know d is equal to what? fxx, fyy, minus fxy squared. Now here you are talking about profit. So therefore, is pxx minus pyy minus pxy squared. Now you don't have to write this, okay? You just do it in terms of p. That's okay. But if you just want to make sure, okay, to make sure that we got it right, so you start from the concept and then relate to the specific application. But it's not necessary, you know, you just give me this thing here because we know that's the formula. So you find the second partial derivative, that will be pxx, pyy, and then pxy. So you got pxx, you know, that is equal to what? The derivative of the px with respect to x, you got -2. And then pyy, the derivative of the py with respect to y, that will be -4. And then you have what? You have pxy. That will be equal to -2. So in order to check that one, you take derivative pyx. Okay, pyx. Do you get -2? Yeah, you get -2. So they are equal. That means everything is correct. So you do the we do the test. So our d now will be equal to -2 multiplied by -2 minus -2 squared. So -2 squared, -2 times -2, that will be equal to 4 minus, okay, -2 squared. -2, no, pyy bukan 2, pyy berapa? Pyy
-4.
94. Itu silap. Sebab dapat 0, you know. Kita pernah buat dibagi d equal to 0. So the test doesn't work. So it doesn't look really nice, you know. This is not a tricky question. This is a question that you want to find the maximum. So make sure, you know, when you put the number, check again the number, you know. Don't if you got 0, you know, or if you got negative, check again, because for application mostly, you know, will be positive. But sometimes I do not know lah, you know. If you check again, you still get the same thing, then of course that will be the answer. So you got 2 times 4, that will be 8 minus 4. So that is equal to 4. And then 4 is bigger than 0. So you know we have a maximum or minimum because the d is bigger than 0. So you look at the second condition, which is pxx. All right. So we got pxx equal to -2. That is less than 0. And then you look at pyy, that is equal to -4, and that is also less than 0. So therefore, what is our conclusion? The function has a maximum. All right. So you can say that profit P has a maximum, or P hat is a profit has a maximum lah, because that's 1 point. Profit has a maximum at x equal to 20, y equal to 5. All right. So you have to establish these 3 conditions. I mean, we call it 2 there. Okay, that's the number 1. And then this thing here, second condition. So both are positive, negative here. So you have a maximum. Now we already say P has a maximum at the point x equal to 20, y equal to 5. So finally, you find the maximum profit. So to get the maximum profit, what do? We substitute x equal to 20, y equal to 5 into that P. Okay? So work it out. So P equal to berapa. All right? And then you will get, this one, just look at the book, $650. Actually, the price, okay, the price is in dollars. The cost is in thousands of dollars. The cost is in thousands of dollars. Now, when you multiply the revenue, yeah. So now, all right, actually the numbers are in thousands. So if, okay, if, because since I didn't mention in thousand, I just mentioned at the beginning, so we just divert a little bit from the example. I didn't say 1,000. I just say the unit of 20-inch lamp, 31-inch lamp. That's the price, okay? So you don't put the 1,000. So therefore, our units are not in 1,000. Slightly different from the book. Of course, after this, you can put in 1,000. So what you will conclude without the 1,000, okay? So what you have here, you just make our conclusion. To maximize profit, we have to sell, okay, not in 1,000, just without the 1,000, 20 units of the 21-inch lamp and 5 units of the 30-inch. Oh, actually, this is not 21, 20-inch. Yani the 31-inch lamp. All right, and the maximum profit is equal to what? $650. So the reason I do this, because when you do application, all right, after you have the maximum point, you got the maximum point or the minimum point, you have to describe what is that point in terms of the units, okay, in terms of the unit of that particular application. Because in the quiz, okay, in the quiz, I have reviewed the quiz with you. There are many people who just found you don't say anything. P equal to minus 50 times 10 equal to 50, 40. Itu bagi. Apa benda tu? Okay, what are you talking about? Okay, so when you answer this question, say something, write something. What is it? It's the price. So just say the market price is. You don't have to say a long sentence. Just say, what is it about? Okay, that's the price. So market price is, substitute. So the price is what? 40 ringgit. So that's why I write here, because I don't want you to just give me the answer. Okay, because if you just do that, I might suspect, okay, you don't understand what you're doing. Okay, so that's the thing. So write a little bit. I don't want you to write an essay, but just to describe, okay? Just to describe what we are doing. Okay, so that is example number 4. So the point here is, okay, one important thing that we are doing is the revenue, okay? So make sure, normally the cost will be given, okay? The cost, you don't have to find the cost. But sometimes you may, but if you look at the revenue will be what? Pxx plus Pyy, because the revenue is the additional of the revenue. Now, if you have to find the cost, then the cost will be similar to that. The cost will be the cost of x plus the cost of y. But most of our question here, the cost, is given already. So we are given the prices. So that means that's the demand function. You can find the revenue, all right? And the revenue is simply that thing. So that is example number 4. Okay, any question about that? So for that part, 14.4, you can give you some questions to practice. Do number 19. Okay, number 19, that is on the profit. And then number 23 on the production. Okay, similar to the example that we were doing, that question is 25. So you have, right? You have the demand, and then you have the or the demand for X and Y, and then you're given the cost, you find the profit. Okay, look at question number 25. Okay, look at question number 25. You have the profit. You have 2 brands of product, and brand 1, brand 2. They just call it brand 1, brand 2. Now, I want you to, for this question, I don't want you to give me the solution. I want you to just set up the problem. All right. Now, what is X? And then what is Y? And then given the cost, I want you to get the revenue. So for that question number 25, I want you to just do that. All right. What is X? What is Y? And what are the units, of course. And then get me the revenue. Okay, do it now. When no, later on, when you go home, not you go home, you're already home. After the class, during the weekend, you can do that question. Okay, buat yang tu. Cari revenue for question number 25. Question number 25. Okay, you got it? Anybody has question on that part? So what is your revenue function? Anybody? I want you to give me your revenue, and then we will get it. Anybody? Okay, what is revenue? Right? Semua tak dapat ke? Nobody got the solution yet?
$70x
70
x
x.
minus x power of 2.
Or you give me the final ni lah. Give me the one that before you get that 70x. Give me the component dulu.
70 minus x
70 minus x
times x
times x. Okay. Plus
plus 80 minus y
80 minus y.
times y.
Okay. Everybody got this? So now the demand function that are given is x equal to function of p. Okay. And y is also a function of p. But that's not what you want. You want function of x and y. So you have to rewrite the functions y in terms of, or x in terms of the prices. Why you do that? Because look at the problem. You want to find, okay, what you want to find. You don't want to find the prices. You want to find what? You want to find x, y. What are the quantities of x and y that maximize profit? You don't want to find px. You don't want to find py that maximize profit. So that function is not what you want. You will want to have what? P as a function of x, because you need to find x and y. Okay, so you have to rewrite. So, but to begin with, you let what is x. Okay, what is x? X is say the brand number 1. Okay, and then y is the brand number 2, of course, in units. All right, unit. And then you have, of course, px, the price of x, and then you got py, the price of y. Or here we use p1 and p2. So given, okay, given the demand function, x equal to 70 minus px. So therefore, what you have now is px equal to 70 minus x. And you do that also for the y. Okay. Y, you will get same thing. So that will be our demand function. And then you put into the revenue. Now there is a tendency, for us to do the mistake, because this is given there. So you can put the revenue equal to px times x. So what you may do will be I just put x, I don't put the y lah. Okay, of course you got the y, but I give you just one component to show, okay, the potential error that you may make. So you got px multiplied by 70 minus px plus that. So you got everything in terms of py and px. Now when you got that, the cost, okay, again here you look at the cost is given as xy. So you make your life difficult. Okay, and then the question say find x and y. Okay, so you have to rewrite like this. But that is not to say you cannot do in terms of prices. if you do it in terms of prices, you can do it the difficult way, but I do not know whether this one can work out or not. So in other words, you have to use the X and Y, ni. Okay? You put P. So I don't know. I don't think so. Yeah, maybe you can do that. You know, you put in ni benda ni. So you multiply 70 minus Px multiplied by the other demand function 80 minus Py. So now you got a complicated demand cost. So that's why, you know, you just go back to what is the purpose of the problem. If it is finding x, y, in other words, you have to make the function in terms of x, y. So that will be the most straightforward thing to do. All right. So that is question number 25. We already solved half of it. Now we move on to 14.5. Now 14.5 is on the Lagrangian multiplier method. This is similar to linear programming. Similar. Right? The problem is similar. It's an optimization problem. You maximize some function subject to another function. So here involve only two functions. In the linear programming, you have objective function is a function, and then the constraints, or yeah, the constraints, they are inequalities. But in this case, we have both functions, and you call it optimization problem. Right? Optimization problem because you maximize or minimize something subject to a constraint. And that method is called the Lagrangian multiplier method. Lagrangian multiplier method. So the problem here is this. You have two functions, and then you want to maximize one function subject to the other. So one is a constraint, the other is the objective. So the problem here is like this. Problem, you want to maximize an objective function. Or is it the objective? An objective function subject to a constraint. And that constraint is also a function. Now it can be minimization. So it can be also minimized. So you have optimization, okay? It can be minimized or it can be maximization of a function of the objective. Okay, you have one function here, the objective, and another function is the constraint. All right. So to be more specific, you want to maximize given our function two independent variables. Maximize z as a function of x, y. That is our objective. Subject to, now I just write st. The constraint, we call it g of x, y equal to k, where k is a constant. Now, why k is a constant? Because that is constraint. Constraint means you have a limit. Then you have a limit, like you have a limit of resources. In the world, you have limited resources. All right. So that's why you put a constant k to indicate there is a limited quantity there, limited amount or quantity. So that's constant. So that is the problem. Okay. You have the objective, which is z equal to f of xy. And then we have the constraint g of xy equal to k. So that is the Lagrangian, that is the optimization problem. How do you solve this? Okay, now the method you solve this is by the Lagrangian multiplier method. So that's the Lagrangian multiplier method is the method, okay, to solve the optimization problem. Now, when you do this thing, essentially what you do, you introduce the multiplier. Multiplier is just another variable. And then you combine the two functions, the constraint and the function you put together. And you define that function as the Lagrangian. So the method to solve is the Lagrangian multiplier method. And this is the method. You define L. Okay, L, you call it L, which is the Lagrangian function. Lagrangian function. Just call it L. And that L, of course, it's a function of x and y, is equal to, not this x, y, because there is another, there's a multiplier, and that multiplier is also a variable. We call it lambda. Is equal to the objective, f of xy, plus the lambda multiplied by the constraint, g of xy minus k. Okay, so that is the Lagrangian function. You come up with combination of the objective and the constraint together. And then they are connected by what? By the alpha, lambda, okay, lambda, alpha to lambda. Okay, by the, we call it lambda. So that is the multiplier. So that's why you call it the multiplier method. And that lambda is a variable. Okay, all right. So now, if you look at the constraint, okay, that you have another form. You have gxy minus k. So what you do is actually, the constraint, okay, the constraint you have what? G of xy equal to k. Okay, that is what you are given, which is the constant k. So you rewrite that. You bring the k to the left, then you got gxy minus k equal 0. So now you got that form, you put it there. So simply by rearranging the terms, okay, you bring the constant to the left, and then that is the form that we want to have to come up with the Lagrangian function. Okay. Now, the Lagrangian function is a function of three variables, x, y, lambda. And the function is only one function with three variables. So when you know that, you don't have to write the L as a function of all these three variables. You simplify it a little bit. Just write L. Okay? L is equal to f of xy plus the lambda multiplied by g of xy minus k. Okay, minus k. So that is our Lagrangian function. You just write L. Now, when you want to solve this, you want to find. Okay, you want to find the optimum point. Okay, what is the optimum point? The optimum point is the value of x star, y star, and then the lambda star. That is the optimum point. But sometimes, for our purpose, you don't need the lambda. Okay, we just need x and y. So therefore, I'll just write x, y. And then maybe what you need is the value, the optimum value. Okay, the optimum value, because you're at the optimum point. So now you want to find the optimum point, the optimum value of the x of the objective. So once you got this, you can find the value of the corresponding value of the function. The optimum value, if the problem is maximized, then you may call it maximum. If the problem is minimization, then that optimum point, you can call it minimum. Okay, that will depend on the problem. Okay, so that's the thing. So when you go back, well, yeah, you go back to the function again. So you get the Lagrangian function, and I already state here minimize or maximize. Okay, so there are two types of optimization: minimize or maximize. So again here, you maximize or minimize. So I just put them together in bracket. The form will be the same. Okay, regardless whether you maximize or minimize, then the Lagrangian function will be the L, which is equal to f of xy plus lambda multiplied by the constraint, where you have to write gxy minus k. So you have to rewrite the constraint in terms of that form. So in short, you just write L equal to f of xy plus lambda xy minus k. And our problem is you want to find the optimum point. Okay, xy, call it x star, y star. And then of course, given that point, you want to find the optimum value of the objective. So it can be maximum, can be minimum, depending on the problem. Okay, clear? Any question about the method? Okay, now, how do you find the solution? Okay, this is how you find the solution. Basically, first, it's like finding the critical point. Okay, like finding the critical point. So we call this first order condition. That means the condition of the first derivative. Okay, first order conditions, we call it FOC. Okay, if you look at the internet, FOC means free of charge. Okay, but here it's first order condition, the first partial derivative. So we call it FOC. What you do here, you take the derivative of the lambda of the L with respect to x. And then you have the derivative of the lambda with respect to y. And since you have another variable, you take the derivative of L with respect to lambda. So there are three partial derivatives. And what are they? So you have to take the derivative of the L. All right? Since there are two terms for the function, so make sure we take care of the partial derivative correctly. All right. Now, if you take derivative of the L with respect to x, what do I get? Give me one term that we should get for the Lx. Anybody? What is the first function that we differentiate? Or what is the first term?
xy.
Fx, y. Okay. So the first term here that is a function of x and y is f. So you take the derivative of f with respect to x, you got fx. Okay. And then secondly, I have a g there. All right. And that g is multiplied by lambda. So I have another term, the lambda multiplied by dx. Now, for the critical point, set that to 0. So I set that to 0 right away because you have three derivatives, Otherwise you have to write again. So call it number 1. Now take derivative with respect to y. Again, you have f of xy. So that will be what? Fy plus you have g, which is a function of x and y. So you multiply that by the lambda, g is equal to 0. Thirdly, you take derivative with respect to lambda. All right. Now you take derivative with respect to lambda, what do we get? What is the coefficient of the lambda?
gxy minus k.
It's the whole thing. Okay, the whole terms in the bracket. So be gxy minus k. So you got g of xy minus k equal to 0. Call it number 3. So the g of lambda, okay, is the constraint. You look at it, it's the constraint. G of xy minus k equal to 0. So essentially that is the constraint, set that to 0. Okay, why you do that? Because lambda here is multiplied by the terms in the bracket here, which is the constraint, gxy minus k. So you take derivative with respect to lambda, what you get? I got gxy minus k. So these are the first partial derivative. You call it the first order condition. So now, given these three things, you have to solve for x and y. So what you do? You have to find x, y. So given this 1, 2, 3, you want to find x, y. Okay, you done? You finished writing these things? If you have not finished, I wait for you. If you have finished, I move on. Everybody finish. I want you to write. Okay, I want you to write the first order condition. Okay, because that is the important component of this method. So I want you to write. When you write, you understand. I remember my teacher. You know, my teacher in in sekolah menengah. You know, at that time, we, the Malay students, we are quite lazy. You know, we don't want to really work hard. But most of my teachers at that time, in the 1960s, 70s, most of our teachers are Chinese and Indian, you know. So that's really, they really challenge us, you know. What one teacher tell me, if you listen, okay, if you hear, what, any of your teacher maybe, come under the same teacher with me. Anybody hear this? If you just listen, okay, somebody just like to be like a boss, you know, just sit down, sit back, and just listen. If you listen, you forget. If you write, you remember. Okay, because if you write, that means you are listening, and also you are writing. When you write, you see. So you are doing three things. You remember. When you listen, you might not see. You can close your eyes. All right. So when you write, you are using your three senses. Need to write, you have to open your eyes. Okay, you cannot be closing your eyes. So I still remember, you know, if you listen or if you hear, you forget. If you write, you remember. Of course, the remembrance may not be very long, but you have to repeat the writing. So I still remember that teacher telling me until now. So I'm sharing it with you. Probably you heard of this, you know, with your teacher, some, you know, before. So you got that first order condition. What we do here, using all these three, you want to find the optimum point. All right. So what you do, you make use of 1 and 2. So 1 and 2, you will make use of these two, just like a system of equation. You will get the following. When you make use of this 1 and 2, you will eliminate the lambda, or lambda will be gone. Get rid of the lambda. Okay, get rid of the lambda, meaning lambda will be gone. Lambda will be gone. You take out the lambda. And then you have x in terms of y. Then you got x in terms of y. Or y in terms of x. Okay, it doesn't matter. You can have this, you can have that. So when you combine the 1 and 2, the lambda will be canceling out. Okay, lambda will be gone, And then you have y in terms of x or x in terms of y. when you have this, you substitute into number 3. Substitute x or y that you get from there into number 3. Now, when you do that, you will get the optimum point, x star, y star. Sometimes, depending on which one you do here, you will get y star first and then x star. But the thing is, you will get the optimum point. And of course, from here, you can find the lambda star, but that is not needed, okay? What you need is only these two. And then from here, you can substitute back into the objective, into z equal to f of xy. Then you have the optimum point, the optimum value, or maximum or minimum value of the objective of f. Okay, optimum means it can be maximum, it can be minimum, depending on the problem. Okay, all right. Any question about this? So that's the method. You make use of 1 and 2. By doing that, it's like a system of equation. By doing that, the lambda will be gone. Okay, lambda will cancel out. And then you got x and y. So you have x in terms of y or y in terms of x. And then you substitute that into number 3. You got x star, y star, that is the optimum point. And then substitute that point into the objective, you will get the optimum value of the objective. Or maximum or minimum. Okay, all right. Now, in order to have a better idea of this, you do by an example. We consider an example. Now, the reason why we cancel out the lambda, you see here, lambda is appearing in 1 and 2. You see, in 1, you got lambda. In 2, you got lambda. So when you consider 1 and 2 to solve it, the lambda you will cancel out. All right? Okay, good. So let's consider an example. So suppose I have this example. Let me see. Example 1. Okay. So I have time. We consider one example, and then I give you another example to work out. Maybe I give you some homework questions. So example, let's say we want to maximize z equal to f of xy equal to 25 minus x squared minus y squared, subject to the constraint 2x plus y equal, no, I'm sorry.
Hello. Hello.
Apa dia? Hello. Anything? Betul. Can you hear me or you cannot hear me? Huh? Anything? Because I heard somebody was saying something. Are you talking to me or you are not talking to me? Okay, so you have that constraint, okay? 2x plus y minus 4. So in order for you to write the Lagrangian, you will have to rewrite the constraint, right? So the constraint, you can do it now or you can do it later, that's fine. So the constraint, you do it. So the constraint now becomes 2x plus y minus 4 equal 0. Okay, so that is the one that you need to write. So given that, or given the problem, you get the L function, which is f of xy plus lambda multiplied by gxy minus k. That's the general form. And put into the specific functions that we are given here. So that will be 25 minus x squared minus y squared plus lambda multiplied by 2x plus y minus 4. So that is our Lagrangian function. So firstly, you need to find the partial derivative. Okay, partial derivative. Take derivative of L with respect to X. Take derivative of the L with respect to Y. Okay, so the first order conditions, Lx equal to Ly equal to L lambda equal to. Okay, now I want you to find Lx. Do it one by one. Okay, first get the Lx. Okay, do it now. You got it wrong, that's fine, because after this we're going to discuss. All right, but I want you to do it first. Make sure you apply the concept. Okay, everybody do Lx. We do Lx, and then you stop. Okay. Okay, everybody done Lx. Siap.
Yes.
The first person who get it, tell me yes. Yes or no?
Yes.
Okay,
Yes,
yes. So Lx is equal to what? You have terms here x squared. So that will be negative
Negative 2x.
So y is the constant. Now there is another term in x here. Okay. So what do you have? You have plus lambda multiplied by the derivative of the 2x is 2. But everything is multiplied to lambda. Okay. So don't forget the lambda. So there will be lambda 2. Or you can write 2 lambda. Now one way that you can use, okay, in order to get the idea, what you can do, you multiply out the lambda with the terms of the constraint. So you can do this, okay? But you don't have to after we are familiar. So you do this. You got lambda to x. That's first term. Multiply out everything. And then you got lambda y. And then you got lambda 4. So that you know individual terms. That will be easier to make sure that we don't miss it and we understand it. Okay? All right. Now, set that to 0. Okay, now do Ly. Okay, anybody, you got Ly?
Yes.
Okay,
Y.
good. So you got Ly. What is Ly? Ly will be what? Negative 2y plus lambda.
Lambda.
Okay, equal to 0. Because lambda is multiplied by everything in the bracket. And you have one term y. So the derivative of y is 1. 1 multiplied by lambda. So you got lambda. Or to get it more clearly, I mean more direct, you multiply out already lambda, you got a term here, lambda y. So derivative of this is what? Derivative of y, derivative of lambda y is just lambda, okay? And then L lambda, as we can see earlier, is simply every term in the bracket. That means the constraint, because the constraint is multiplied by lambda. You take the derivative of lambda with respect to lambda is 1, all right? So 1 multiplied by everything in the bracket, that's exactly the constraint. So you got 2x plus y minus 4 equal 0. Or you can do the derivative individually. So you got lambda 2x, derivative with respect to lambda 2x. Here you got lambda y, differentiate with respect to y. What you get? Y. And here you got negative lambda 4. So differentiate with respect to lambda, I got 4, negative 4. So that is our number 1. That's number 2. That's number 3. So here, okay, you make use of 1 and 2. In doing so, we are going to cancel out the lambda. All right. Now, how do we do that? We do it this way. I mean, you just set everything equal to lambda. Okay. So from number 1, what do I get? I get lambda equal to, you bring the x to the other side, lambda equal to x. Betul tak? Because you got 2 over 2. Okay? 2 over 2, x lah. And then from number 2, you have lambda equal to 2y. So lambda equal to x, lambda equal to 2y. Therefore, x equal to 2y. So one straightforward tip or one method, very simple. You set everything as what I have here. Lambda equal to some x in y and y. From number 2, you also set lambda equal to some x and y. So it's very simple because x and y separately. And therefore, you equate these two, the lambda will be gone. So you got x equal to 2y. Or, if you want, y equal to half x. So either you use this one or use that one, it doesn't matter. Okay? And then you put back into number 3. Okay, don't put into number 2. Don't put into number 1. Because you will go in cycle. All right, you will go back what you have started. So put in 3. So now when you put in 3, then what you get? Okay, are you done? Are you done here? Finish, yeah?
Yes.
Finish?
Yes, sir.
Okay, if you don't finish, I will wait. Okay, I want you to write. Ni, benda ni. Okay, that's the important part. That's the method. So when you do that, you got x equal to 2y, substitute. Okay, substitute x equal to 2y into number 3. Okay, into 3. So what you have now is you got 2, okay, multiplied by 2y plus y minus 4 equal 0. So now everything is in y. So you got 5y equal to 4, y equal to 4 over 5. Betul tak? Y equal to 4 over 5.
Yes.
Betul tak? Huh? Check lah. Betul tak? Okay. Y equal to 4 over 5. To find x, then we will simply substitute into x. You can use 1 and 2. But 1 and 2, you have the lambda. You use this one, okay? Where you already have x in terms of y. Substitute into x equal to 2y. That will be equal to 2 multiplied by 4 over 5. That will be 8 over 5. So that's the value of x. So you call this y star. That will be our x star. Right? So that is the optimum value of x and y. And then the problem that you have is to maximize the objective, right? So the optimum value of the objective, or since you already have the optimum point, so you can say the maximum, okay? The maximum value of the objective. How do you find it? We substitute again. X star equal to 8 over 5. And then y star equal to 4 over 5 into the objective, all right? Into z equal to 25 minus x squared minus y squared. And then you substitute, what do I get? I get equal to 25 minus x squared, 8 over 5 squared, minus 4 over 5 squared. Okay, Bagilah, berapa dapat? Okay, anybody has calculator? Can you find that value? Because I don't have it.
21.8.
21.8.
31 point
21.
21
21.8.
0.8. 21.8. So that is the maximum value. So we conclude saying that the optimum, okay, we can say the optimum value of X is 4.5. I'm sorry, 8.5. And the optimum value of Y is 8.5, 8/5, I'm sorry. And the maximum value of the objective, given the constraint, is 21.8. All right, okay, good. Or you can see this. To maximize, okay, the function, whatever the function is, to maximize the function, which is equal to 25 minus x squared minus y squared, given the constraint, right, given the constraint, the optimum value of x is 8/5. The optimum value of y is 4/5. And the maximum z is equal to 21.8. Okay, something like that. Okay, so that is the Lagrangian multiplier method. Now, in application, okay, in application, what we do here is we look at two examples. Example number 4. These are all economic example. Application number 1 is utility maximization. Now, you know, in economics, for consumer behavior, what do we assume, or what is the behavior of the consumer? Now, for the consumers, you maximize, all right? Maximize utility. What is the constraint? There is a limit to the maximization of utility, all right? We maximize utility subject to what? Subject to the income constraint. Okay, income constraint or the budget constraint. I think for this one, I need to discuss a little bit the budget, you know, utility. So I don't have the time. We will have to continue next time. Okay, so we continue next class, but I would like you to read, okay? Read the example 4. Next class, we will go into more detail. Example 4, example 5, on the utility and the production. So basically, these are the application that we're going to look at. Huh? Okay, all right. I think I need to spend a little bit more time. So now we don't have enough time. So we stop here for today. And again, I want to repeat, our test would be test tapi kita cakap berapa bulan?
21st.
21st.
Test is 21st December. Okay, the class on Monday, two Mondays from today. Okay, 21st. So I give you enough time. Inshallah, everybody can prepare. Okay, hopefully everybody will do better in the test than the quiz. Okay, all right, good. I will see you again. Assalamualaikum warahmatullahi taala wabarakatuh. Have a nice weekend.
Thank you.
Waalaikumsalam.
Don't go out.
Have a nice day.
Topik ni banyak bagi ni.
Yes, sir.
Okay, thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Pagi ni sejuk lah. Dekat Pahang hujan ke? Pahang Kelantan Terengganu hujan ke? Ke tak hujan lah?
Hujan.
Hujan lebat lagi? Any weather report from the Pahang, Terengganu, Kelantan? Ke hujan dah stop dah? Okay, I'll see you again. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Hai, sedih ni bunyi apa pasal?
The 21st December, right? The quiz, the
Yeah.
test. Thank you, sir.
No reason to excuse, okay? There'll be no excuse because I do the test during class time. So
Yes, sir.
that one is confirmed our time. So nobody can take away that time from us.